Assalamualaikum warahmatullahi wabarakatuh. My name is William Prakoso. I'm from electrical engineering and I'm from class I. And in this video, I will explain about three-phase rectifier, half wave and full wave. And this is about the explanation of module 5 in power electronics or ELDA. The understanding of three-phase rectifier. The three-phase rectifier is the process of changing power stable three-phase supply into a DC power supply keep using a solid-state diode or thyristor. And the advantage here is that the circuit three-phase rectifier can be used to give power in many industrial applications such as control motor or battery charging that require higher power requirement than can be provided by one-phase rectifier circuit. The next is half-wave three-phase rectifier explanation. Half-wave three-phase rectifier. The anode of each diode are connected to one-phase supply voltage with the cathode of all three diodes connect together to the same positive point. Effectively creates a diode type setting, or in this general point becomes the positive terminal for the load, while the negative terminal of the load is connected to a natural supply. Assuming rotation of the red, yellow, blue phase, or we can call it VABC, VA, VB, VC, and the red phase as a VA. Start at 0 degree. The VA is start at 0 degree. The first diode to be run is diode 1, or can call it D1. Because of that, it will have a voltage which more positive at anode than diode in D3 or D2. Does the D1 diode run for the positive half cycle of VA, while the D2 and D3 are in reverse bias state. Neutral wire provide a return path for load current back to supply. 120 degrees electricity, then diode 2 or D2 start running for a positive half cycle of B or yellow phase. Now the anode is more positive than the diodes, or D1 and D3 both are off. Because of that they are in the reverse bias. Similarly, 120 degree, then VC or blue phase begins increase turning on the diode 3 as its anode become more positive, so it turn off. And then this is the circuit image or circuit picture of half-wave three-phase rectifier. And then this is the wave image of half-wave three-phase rectifier. For this rectifier, the supply voltage such as VA, VB, and VC are balanced, but with the 120 degree difference, and then it's giving VA, and it is giving some formula like VA equal VP times sin omega t minus 0 degree, and VB is equal VP times sin time omega t minus 120 degree, and VC is VP times sin VC is VP times sin times omega t minus 240 degree. And then because of this formula, the average of DC value from this circuit is VDC equal to 3 root 3 per 2p, and VP is equal to 0.8 to 7 times VP. And then we move to the full wave 3-phase rectifier explanation. Assume the rotation of red, yellow, blue, and VA, or we call it VA, VB, and VC. The red phase, or as VA, is set on 0 degree. Each phase are connecting the pair of diode, one pair of diode of positive conductor power load, while the other diode is in the negative side power load. Diode D1, D2, and D3 and D4 is forming rectifier bridge between unappraised and P phase. It's same with diode D3, D4, and D5. It's passing the positive rail and depend on something which have more positive voltage in the terminal anode. And then we move to the circuit picture of full wave 3-phase rectifier. This is the picture of circuit full wave 3-phase rectifier, and then this is the wave image of full wave 3-phase rectifier. You can see it. You can see that the shape of the result shape of wave from full wave 3-phase rectifier circuit. The explanation is when 3-phase is rotated through the rectifier terminal, the conduction is passed from diode to diode. Then each diode is running around 120 degree in every supply cycle. But because need 2 diodes to run in a pair, each pair of diodes will run only 60 degree from the cycle in one time. The average DC value from the output voltage waveform from this circuit is VDC equal to 3 root 3 per P times Vs equal to 1.65 65 times Vs. And then we move to the trial table of half wave and full wave 3-phase rectifier. This is the picture of the trial table that if you want to find the result from this circuit, like there are trigger degree T1, T2, T3, and RMS, and in V input there are RMS and max, and in V output there are RMS and average, and I output there are RMS and average. And in full wave actually it's similar with the half wave, but there are additional thing, like in trigger degree they have T4 and T5 and T6 as additional. Maybe that's all my explanation about module 5 about 3-phase rectifier. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.